Hello and welcome to this lesson. We're going to be learning about sets or set theory. So imagine you walk into your room and you decide you want to arrange your room. You have your books, you have your clothes, you have snacks and other things around in your room. When you want to arrange these things together, you put all the books to one side, you put all your clothes to one side in your wardrobe, and you put all your snacks to one side. What you have just done is create sets without even realizing. So, we're going to learn other aspects of sets. We're going to see how we use sets in everyday life. Let's look at a little bit of history. The concept of sets was formally introduced in the 19th century by a German mathematician called George Cantor. He used this to study infinite numbers and created the foundation of mathematics. Now, set theory is the language of mathematics. So, from solving equations to understanding probability and logic, everything starts from here. So, what exactly is a set? A set is simply a collection of distinct and well-organized objects. Objects in a set are called elements or members of a set. For example, the vowels in the English language can be called a set. So we have a set of vowels, and in this set we find A, E, I, O, and U. In math, we also have a set of even numbers or a set of odd numbers or a set of prime numbers. So a set of even numbers less than 10, for example, would include 2, 4, 6, and 8. Remember we said distinct and well defined. So this is usually the key criteria for you to call something a set. It has to be distinct and well defined. So anytime you say a set of vowels, one would always know what you're talking about. And anytime you say a set of even numbers less than 10, anyone listening to you can be able to, guess or can be able to tell you all the numbers involved. You can also say a set of prime numbers below 10. So this would include 2, 3, 5, and 7. Sets are usually represented using curly braces. Let's learn about something called, set notation methods. Set notation methods are just basically ways that sets can be represented. So we have the description method, we have the listing or roster method, we have rule or set builder method, and then finally we have the Venn diagram. For the Venn diagram, we're going to create a completely different lesson so we can cover this topic in depth and cover it properly. The description method is where we describe the elements of the set in words. So for example, we can simply just say the set of all odd numbers less than 10. This is the description method. You can also say the set of vowels in the English language or the set of consonants in the English language. So basically just saying it in words, just as we have words and we have figures. The second method, which is the listing or roster method, is where we list out each element clearly separated by commas. So those are the name implies, you list them with commas. So for example, to write this, if we wanted to write the set of vowels in the English language, we would write A, E, I, O, and U. You can write a set of odd numbers from 1 to 10. This would be 1, 3, 5, 7, and 9, all with commas. So this is how we write when we're talking about listing or roster method. And then we have the rule or set builder method. And here we define the set using a rule. So for example, just as we did in the set of all odd numbers less than 10, under the rule or set builder method, we're simply going to write this as the set of x, where x is an odd number and x is less than 10. Here we're making use of both, letters, numbers, words, and symbols. And then we have Venn diagrams. Venn diagrams is when we represent sets using circles. So, example, we can show two circles overlapping for two sets of numbers. Let's talk about the types of sets. There are many types of sets. We have the empty set, also called the null set. We have the finite set. We have infinite set. We have universal set. We have subsets, power sets, and then equal sets. Let's look at them individually. The empty set or the null set is a set that has no elements. Yes, a set can also be something that has nothing inside. For an example, let's say the set of natural numbers that are less than 0. In this set, we can't have any number, so this would be an empty set or a null set. Under finite set, this contains a countable number of elements. So something you can easily count, or something you can count in general, whether easily or difficultly. An example would be a set of numbers less than 10. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This can be easily counted. We can count numbers from 1 to 10, from 1 to 20, from 1 to 1,000, 1 to 1 million, and so on. So what happens when we cannot count these numbers? This is what we call infinite sets. This is when the elements or numbers become uncountable. For example, counting the numbers from 1 to infinity is uncountable, or numbers listed as 1, 2, 3, 4, and so on. We cannot really tell where this number actually ends, so in essence, it is uncountable. Next, we have universal set. This is often represented with the letter U. Now, this set contains all possible elements under consideration. For example, if we're talking about the letters of the alphabet, when we're talking about the universal set, this would include all the letters from A to Z. This would be the universal set. So, the set that contains all the possible elements under the consideration. If we're talking about food, the universal set would be all the food that we can find in all countries of the world. So food we can find in the USA, food we can find in Nigeria, foods we can find in Russia, food we can find in China. So and so on, all the countries around the world. Now, the universal set doesn't necessarily mean it has to be very, very large. For example, if we're talking about a set of numbers from 1 to 10, the universal set in this scenario would basically just be 1 to 10. Talking about a set of numbers from 1 to 1 million, the universal set would be numbers ranging from 1 to 1 million. Talking about a set of countries, universal sets can be 1 country, 2 countries, 3 countries, 4 countries, 5 countries, and so on. The universal set doesn't necessarily have a limit. It's just what we are considering at a particular time. This leads us to something called the subset. The set A is a subset of B if every element in A can be found in B. So basically, if we have two sets, set A and set B, where set A has numbers 1 and 2, and set B has numbers 1, 2, and 3. Based on our definition, we can say that set A is a subset of set B. This is because all the elements in the set A, which is 1 and 2, can be found in set B. So then we have something called the power set. The power set is the set of all the subsets of a set. all the possible subsets that any set can have. So if we have a subset B, which is a range of numbers from 1 to 10, the power set is all the possible subsets that we can form from this one set B. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, subset A can be 1 and 2, subset B, or let's say subset C can be 1, 2, 3, subset C can be 1, 2, 3, 4, and so on. We can also have, single sets, which is just one individual element, which is just 1 or 2 or 3. So since this can go on and on and on and on, we can simply solve this using this formula. The number of elements in set A is equal to 2 to the power of n, where n is the number of elements in the set. So basically, the set M is equal to A, B, and C. Using this formula, we can simply calculate the possible number of subsets. So n will be equal to count the number of elements in this set, which is 3. So 1, 2, 3. N will be equal to 3. So this will become 2 to the power of 3. 2 to the power of 3 is 8. So we have 8 possible subsets. So this leads us to equal sets. Equal sets is when two sets have exactly the same elements. Not the same amount of elements, but exactly the same elements. So for example, if set A has 1, 2, and 3, set B will also have 1, 2, and 3. The arrangement doesn't really matter. So set A can be 1, 2, and 3, and set B can be 3, 1, and 2, or 3, 2, 1, or 2, 1, 3. But as long as both sets have the same element, exactly the same element, they are called equal sets. So I know you're getting a little bit tired, but let's talk about one more section before we round up for this video, and that is set operation. So under set operation, we have a couple of operations that we can do, when we talk about sets. So this is, union of sets, intersection of sets, and then complement of sets. It's important for you to know all these terms so that you can, easily master set or the set theory. So the union of sets. The union of sets is basically combining all the elements from 2 sets or 3 sets, or basically combining all the elements between a given number of sets. So for example, if we have set A and we have set B, set A is 1, 2, 3, and set B is 3, 4, and 5. When we combine both sets, we would have 1, 2, 3, 4, and 5. So this is a union of both sets. When combining, you do not have to repeat numbers that appear twice. And if we have, for example, if we have sets M and set N, where set M is equal to 2, 3, 5, and 7, and set N is equal to 2, 4, and 6, the union of set M and N would be 2, 3, 4, 5, and 6. Let's talk about intersection. The intersection of two sets, A and B, is the third set containing elements that is common to both set A and set B. So basically, the intersection of sets is a set that has only the common elements between two sets. So in this scenario that we have 1, 2, and 3, the intersection of this would be 3. This is because both sets A and set B have the number 3 in common. That is the only number that they have in common. So let's say if they have, if both of them have 6s, this will become 3 and 6. So for example, if we have the set M, which is equal to 1, 3, 5, 7, and 9, and set N, which is equal to 1, 2, 5, and 7, the intersect of these two sets would be 1, 5, and 7. So finally, let's talk about complement of sets. The complement of a set A is the set of elements which do not belong to set A but are present in the universal set. So basically, this means elements that are in the universal set but that are not in A. So if we have the universal set U, which is equal to 1, 2, 3, 4, and 5, and then we have another set which is 1 and 2, the complement of this set A will be equal to 3, 4, and 5. This is because these are all the elements that are present in the universal set that are not present in A. For another example, if the universal set is letters of the alphabet, so we have A to Z, and then we have another set which is vowels, that's A, E, I, O, and U. The complement of A in this scenario would basically just be consonant. So if you found this video helpful, don't forget to like, share, and subscribe for more math lessons.